Last time we talked about while loops. Today we'll talk about for loops, which are another structure we can use for looping, and these are specifically good for count-controlled loops. The reason for that is they combine a bunch of the different little pieces that we need in order to make a count-controlled loop. Okay, so the general format is this. First, we initialize our counter. Then we test that counter to see whether we should enter the loop. If it's true, we enter the loop and do whatever the statement is. Then we update our counter, and then we go back here to check our counter again. If we only have one statement inside the loop, we actually don't need curly braces. That's a lot like an if-else construct. If we do want to do more than one thing in the loop, which most of the time we will, then we definitely need curly braces. And I would say good practice, always include curly braces. That's just the smart move. So again, let me go through that one more time just so we can get a sense of what the flow looks like. We start by initializing whatever counter we're going to use to keep track of where we are in this count control loop. We test that counter to see whether we should enter the loop, and if that condition is true, we enter and do whatever's inside. Then we go update our counter to whatever the new value should be. Typically, we're going to be adding one or subtracting one to it. We go back and test our counter again with the new value. If it's still true, we enter the statement, do the statements, update the counter again, test the counter again, and so on. And that's really the action of the loop. One thing that should really distinguish this from a while loop is the fact that initializing the counter happens as part of the structure of the loop. Let's look at an example. We saw this implemented using a while loop in the last lecture. Now we'll implement it with a for loop. So let's see. We declare a sum variable and initialize it to 0. We also declare a counter that we're going to call I. So first we initialize I inside the loop. While I is less than 100 is our condition, there's only one statement in the loop, which is sum plus equals I. So take whatever sum is and add I to it, and then we increment I. And then we go back and check again. So if I is starting at 0, at first 0 is less than 100, and so our condition will evaluate to true. We'll enter the loop, do the statements, increment our counter from 0 to 1, do it again. And we'll just flow through this circle over and over again. Now, we can change something slightly about this. You'll notice that right up here, our counter is declared outside of the loop. We could also change it so that we declare our counter inside the loop, right here. So rather than declaring int I out here, we declare int I inside the structure of the loop. We like this a little better. Okay, declaring the counter inside the loop, generally, we find that to be a little bit better for our needs. We'll talk more about what exactly this means in the future, but the main idea is that it means that this counter variable, I, is only visible inside this loop. Okay, it's only visible inside this loop. And it means that when the loop is finished, this variable disappears and we can't access it anymore. That's pretty good because it means that if we do a loop later on, we can again declare a new counter called I and use that for the next loop with no problems whatsoever. So there's no confusion, there's no possibility of running another loop with a counter that we already used that starts at a different value. Okay, so as another example, we're going to look at a program that asks the user how many numbers they want to enter and then finds and prints the average of those numbers. So we'll open that up in Eclipse right now. Here is a program called compute average. The purpose of this program is to ask a user how many numbers they would like to average, then to have the user enter each of those numbers one by one, and then to generate and print the average of those numbers. Pretty straightforward. Okay, we import scanner, make a new scanner object, declare a couple of variables. One is going to hold the number of inputs. One is going to hold a running sum of the numbers that the user has typed so far. Okay, we prompt the user for how many inputs they'd like to enter. Then we go through a for loop. We start that for loop at 0, and we say as long as our counter is less than the number of inputs, well, we're going to enter the for loop. We'll prompt the user for a number. So enter number 0, enter number 1, enter number 2, and so on. And then we'll actually add that input from the user directly to the running sum. Sum plus equals reader.nextDouble. So we're actually not even storing the user input in its own variable. We're immediately adding it into that running sum. We do that until our counter exceeds the number of inputs, and then we exit the loop. We check to see if the user said that they wanted to enter 0 or a negative number of inputs, and if so, we say, okay, you gave me no numbers. I have a typo there. Otherwise, if the user entered in a positive number of numbers, then we print the average. The average of the num inputs numbers you gave me is sum divided by num inputs, which in other words is sum divided by num inputs. Let's run it and see if it goes. Okay, run compute average.java. How many numbers would you like to enter? Let's enter in 5 numbers. Okay, number 0 is 1.5. Number 1 is 4.4. Number 2 is 7.3. Number 3 is 100.5. Number 4 is 7.7. The average of the 5 numbers you gave me is 121.4 divided by 5.0, which is 24.28. Now, this is a little bit annoying. There's some little formatting stuff that I don't really like that much here. The average of the 5.0 numbers you gave me. Well, the user's never going to give me a fractional number of numbers. They're never going to give me 5.5 numbers. So it doesn't really make sense to have that be stored and displayed as a double. So let's go ahead and change our data type up here from double num inputs to int num inputs. Okay, but that means that sum then becomes an int. So let's take that to a new line and re-declare that as a double one more time. So let's run this again. We'll enter in 3 numbers this time, 1.6, 90.5, and 4.3. The average of the 3 numbers you gave me is 96.39999 divided by 3, 32.1333333. There's more formatting we could do, but for our purposes, this is doing what we need. Fantastic. Okay, you go ahead and try writing a pretty simple for loop. All we want is to ask the user for an integer n, and we want to print out all the numbers from 0 to n inclusive. You can call it print all numbers. Then I want you to modify it so that you print all of the numbers on the same line, just with spaces in between them. Okay, that'll be a good little exercise for you to make sure you understand how to put together a basic for loop. Now, one question that remains is, when do I use a while loop? When do I use a for loop? All right, well, certainly if you're using a task-controlled loop, okay, there's a good chance you want to use a while loop. But honestly, the two structures are not massively different. There are 2 advantages to for loops, particularly if you're using count-controlled loops. The first is all of the loop control info, including the counter variable that you declare, is in the for loop's header. It's all there in one place, which is kind of nice to have it all wrapped up in one little package. Second thing is that because the loop counter is contained in that loop, and because that counter disappears afterward, after the loop is done running, you can use that same counter again later with no problems, no complications, no nothing. So not having to worry about accidentally reusing a counter, about resetting your counter, all that kind of stuff, that is, it's nice to have that not be on our mind. Okay, after you've tried that initial simple for loop, the things you want to be able to do are, first, describe the flow of action in a for loop. We start with initialization, we test against the condition, do our statements, increment, and then we go back to the test and follow that loop throughout. You want to be able to write and read simple for loops. Tell me what are some differences between while loops and for loops, and why might you choose one over the other. And we're going to trace through a bunch of simple for loops to predict the output. You're going to get tons of practice on this, on your problem sets, and on activities we're going to give out in class. So fantastic. For loops are going to be a bread and butter structure for you. So I hope this was pretty straightforward. Have a great night.